Okay, moving on to the final to the last subsection, which is the chemical potential. And the partial molar Gibbs energy is such an important quantity in chemical equilibrium that it is given a special name, which is the chemical potential, which is defined by this following equation. Okay, the total function and partial molar function, we seek an expression for the total quantity K in terms of its partial molar quantities. This can be found by integrating decay. Because since K is a state function, we may choose any path we choose. Okay, so from this, since the partial molar quantities Ki depend only on the composition of the system and not the total number of moles in the system, they are intensive quantities because it does not change. Uh, Sorry, it change, and we may choose a path such that each mole fraction xi is constant. So from this arrangement, we can get this final equation, and where we may take the summation outside the integral, right? This one outside the integral, because k1, aki, and xi are constant. So integrating this give k equals to ki and I, the summation of this one. So the typical problem using this formula is to find K2 given the total K and the composition of the solution. So basically, uh, these are the most common questions that usually has been asked because the total K is given here, the summation of all K, and to find the K2, which is maybe it can be K1 plus K2. And for last one is the Gibbs-Duhem equation. The Gibbs-Duhem equation is another useful means of relating partial molar quantities. Its derivation is very simple and it uses the result given above. Taking the differential of the last equation, so we can get from our definition, we can get this one. And from our definition of partial molar quantities, so dk equals to kn plus k Tn. And at constant p and t, so it should be dk equals to summation of k Tn because it's constant p, there's no changes of uh, the pressure and temperature. And subtracting these two equations give this one at constant p and t. So this is known as Gibbs-Duhem equation. This is very simple because it is summation of kn equals to 0, whereby this is how it relates the partial molar quantities. Again, K may be any extensive thermodynamic properties, sorry, function, example G, A, U, S, H, C, P, V, etc. And the function to which the equation is most often applied are G, that is mu, V, S, and H. Okay, okay, just to wrap up, in the comment section down below, I want you to list down only 3 important highlight of this chapter. You don't have to elaborate, just 3 keywords of this chapter. Okay, all right. See you in the next chapter.